Okay, to look at the sum and product formulae, we're going to start with two of the compound formulae for cosine. If we add these two together, then we'll get an equation where the right hand side looks like this, which has the two sine terms which can be cancelled out because this one and this one are equal to each other. So that leaves me with two lots of cosine times cosine for the two different angles. So here we can transfer two sums of angles to one product, or one product to two sums. If I divide both sides of this equation by 2, then it leaves me with a cosine times cosine equation, which can be split up into two products, both divided by 2. Two sums rather. So to convert this example from product to sum, for instance, if I've got 2 times the cosine of 50 degrees times the cosine of 5 degrees, then here's my equation, my formula. Identify A and B. A is 50 degrees and B is 5. Then that leaves me with cosine of 50 plus 5 and cosine of 50 minus 5, which simplify to cosine of 55 degrees plus cosine of 45 degrees, which can be evaluated separately. Right. One more example of sums to products. Right. If we look at this example, you can see here's the formula and here's the question, and the product on the top is only half of the product on the bottom. We've got 2 sine A sine B. So all I have to do is divide both sides of my formula by 2. So the two sums will be divided by 2. And now I just go back to identifying my two angles, x plus pi over 2 and x minus pi over 2. So I'll use this new version of the formula, and that will leave me with sine A times sine B equals cosine of A minus B, which is 2 pi over 2. 2 lots of pi over 2 minus 2x, and I mustn't forget to divide both sides by 2, so that's the divide by 2 for the right hand side since the 2's gone on the left. And if we remember what the cosine graph looks like, at cosine of pi the value of the graph is -1, so I can substitute out cosine of pi for -1 over 2 minus negative cosine of 2x over 2 as well. Right, we can do this backwards. We can also go from a product. We've gone from a product to a sum, so we can go from a sum to a product as well. So I'm just going to identify these two angles inside the sum half of our formula. A plus B, we'll call that C, and we'll take A minus B, and we'll call that D. If I add C and D together, I'll get left with two lots of A. So therefore A, in terms of C and D, is C plus D over 2. I'll just do the same for C minus D. This will leave me with 2B is equal to C minus D. So B is equal to C minus D over 2. Right. So looking at the left hand side of this formula, the product side, if we substitute out A and put in C plus D over 2, and substitute out B and put in C minus D over 2, that leaves us with a slightly tidier formula on the right hand side, cos C plus cos D. Okay, so here we've got the sum half, and now we can take it back to the product half. Here's the rest of those formulae. Note the bottom one's a little bit different, but you can work those out for yourself just the same way as I did there. Right, here's an example. If I've got sine of 8x plus sine of 2x, then using the sine plus sine version of the sum to product version of these formulae, two lots of this formula times that part. We just identify our two angles again, same as before, substitute them into the equation, So c plus d is 8 plus 2x, then we divide by 2. C minus d is 8 minus 2x, divide by 2, leaves us with this equation here. Alright, this one's a bit trickier. This is using the sums to products rule to prove an identity. So I'm going to prove that sine 2x plus sine 5x over cosine 2x minus cosine 5x is equal to cot of 3x over 2. Here's the two. We'll use the top and the bottom one because we've got a sine plus sine and a cos minus cos. So there they are there in purple and green. And if we'll just start with the top half of the formula here. C plus d is 7x, divide by 2. Cos of c minus d is negative 3x over 2. Because c is the 2x and d is 5x. Right, we'll just do the same for the bottom. The formula says negative 2 times sine of c plus d over 2, so that'll be c once again is 2x and d once again is 5x, so add them together, 7x over 2 from there, and be sine of c minus d, which is negative 3x over 2 once again, just the same as the top line. Now if we take a quick look at the cosine graph once again, so here we have cosine of x, and x is going to the right. If we also add an x going to the left, and we draw the graph there, you can see it's a mirror image. So that means that any point for x on the cosine graph will be the same as if you took the negative x value and plugged it into the cosine graph. So that means that cosine of negative 3x over 2 is the same as cosine of 3x over 2. Here we look at the negative sine negative x function and compare it to the sine of x function, and as you can see, they lie on top of each other, they're the same thing. So negative sine of negative x can just be replaced by sine of positive x. So there I can get rid of those two negative signs. Right, we've got a common term in the numerator and the denominator, so they can cancel out, which leaves me with cosine of 3x over 2, positive, and sine of 3x over 2 on the denominator. You and I both know that tan is equal to sine over cos. Therefore, 1 over tan is equal to cos over sine, and 1 over tan, we also know that is cot or cotangent, which means that where we're up to now can be written as cotangent of 3x over 2. And that's the right hand side, so we're done in just over 8 minutes. That ends.